In this video, we're going to take a stab at solving one of the challenges in Snyk's CTF that was hosted the previous week. If you haven't watched one of the last episodes that I posted or one of the last videos I posted, I talked about how they're doing a few days of a CTF, and this challenge comes out of that particular CTF itself. So let's jump in and take a look. As we open up the challenge, this is what we're presented with. Organic sauerkraut, I hope I'm saying that right. You're given a link to a open API doc. So we're going to click on this and actually open it up. At a first glance, all we see is this is Swagger or open API documentation. It tells you what endpoints are available and what can you send to these endpoints. And the first thing we can see is say hi is one of the endpoints, and there's also all the way at the bottom there's say bye. Each of these take a string name and they give you a response. And we can actually try it out by clicking right here and then clicking the execute button. So we can say name is nahamsec and it's going to give us a curl URL. And if we make this curl to this URL, it's going to give us the response, hi nahamsec. At a first glance, this isn't a vulnerability on its own. There is nothing we could do here. Again, I come from a background of a bug bounty hunter, and I look at everything as a place where I could inject things. But in CTFs, usually we want to get some sort of a server side or some vulnerability that could let us read a flag wherever that could be. In most cases, it's a file on a server, it's in the environment variables. This all depends on how the CTF is created. But in this case, I don't think an XSS or some other vulnerability would be feasible here, but we're going to go back to the challenge because they have also given us this file called requirement.txt. So I'm going to quickly switch over to our terminal, and in terminal we can see I'm going to do a list, and we can see there are two files. This is the exploit that we're going to talk about later on. There's also the requirement files. So in requirements, what we can do is we can see what dependencies or what other libraries or whatever this application is using. There is uvcorn, rpc.py, and pydantic. I think how you say the name. I'm sorry if I'm butchering this. The first thing I wanted to do, because I know what business Snyk is into. Snyk is a company that they look at source code review. So I'm going to take a look at and see if they offer anything with requirements.txt. So we're going to type in requirements.txt, and we can see that they have something that says check your requirements text.health, and hopefully by going here and uploading our requirements.txt, it gives us some sort of an information for what we're looking for. And we can see right here it comes back in two of the packages, uvcorn and pydantic. They're both at a good health, and the other one needs review. As you can click on it, it says package health score is at a 57. I'm not sure why, but it looks like something may have been wrong with this package. And I was hoping here we can see a vulnerability scan, but unfortunately it looks like that's not the option. So we're going to switch to the Snyk CLI now. And with the CLI, what we can do is we're going to just pretty much install the requirements for our requirements.txt. We're going to pass it to Snyk and have it to do a test. We're going to assign it the file requirement.txt, and we're going to tell it it's for Python 3. And as we run this, it's going to install the requirements. Because I've already solved this challenge, it's going to say that the requirements have been already met. It's going to skip that part, but then it's going to feed all of that result into Snyk and test out and see if there's any vulnerability attached to them. And as we come back, we can see that there is one vulnerability coming back for rpc.py.0.60. And if we scroll down all the way here, it gives us some path. The license is enabled, my project name. But what I'm looking for here is a link to see it right here. It says security snyk.io, and it gives us a link to a vulnerability. And we can see there's an RCE in this case. It's marked as a 9.8. Obviously, it's critical because it gives us access to run commands on this box. And we're going to go look at this actual exploit on exploit.db. And if that doesn't work, well, it looks like it works. We're going to take a look at this and see what this exploit is. So what I'm seeing here is that it requires pickle, so I'm assuming there's going to be some pickled payload we're going to send over. And it looks like the header that we're sending over is pickle. It does some things. It takes our payload right here. It feeds it to pickle RCE. It creates our payload, and then down here it sends us to the URL, which is our host that's vulnerable. Then we're going to send it the payload as the data, and of course the headers are the headers that we're going to see. I'm assuming here, because they're putting this header here, it says header needs to have serializer pickle. It's something that is required by this on one of the headers when we want to send a request. So again, what I mean by that is right here we can see they're sending a header that says serializer is JSON. Without it, it will not be vulnerable. So the key here to exploit is we want to assign a serializer as pickle, like that I've done in this proof of concept right here. So for this to work, we're going to need three things. Of course, we needed Snyk, because it made our life easier. You could have done this manually. You could have taken one of those requirements, copy pasted them into Google and looked for vulnerabilities. Very manually, you could do that easily. But again, think about it as if there are more requirements, the more work you have to do. So lucky for us, there were 3 requirements. I could have done it manually or just fed it to Snyk and have it automatically do it for me. So the second thing we're gonna need is we're gonna need a command shell. We want to write Python because this proof of concept requires Python. And the third one is we want to do a reverse shell from that box, the application box that we're hacking into our box to read the flag. So what we're going to do is on one of our terminals here, both of the same terminal. One is I want to use it for my open ports for netcat, so NC. So 8080 is open and ready to receive that reverse shell. So what we're going to do now is we're going to take a look at our exploit. And as we can see here, I've set the host to the host of the CTF. Don't make the same mistake I did. You don't want to put the HTTP here. In the first few attempts, I put HTTP there, and it turns out they're already assigning it to the URL where the host is later being assigned. And we're going to make a request to say hi. I'm assuming that would also work with say by or say by whatever the other endpoint was. And then obviously we have to make sure we set our headers where serializer is pickle. It wouldn't work with JSON or other ones. And all the way at the bottom here, we're going to test out 2 things. Again, obviously I've solved this already, so I know what the solution is, but I'm going to first do a uname just to see if anything comes back. So we're going to go Python 3 exploit.py, and it comes back and gives it to us. This is the payload that would be created and sent to the server, but we are not getting any connections or any actually output coming from this. So I'm assuming we have to for sure get a reverse shell and that we cannot see the output of any of our commands. And we can also try something like curl. So instead of doing, let's see it for it. So instead of doing this command, we're going to do exec command and we're going to give it curl. I usually assume for a lot of the CTFs that curl or wget are not available, but I'm going to try it anyways. And then we're going to do the same thing. And again, it comes back. It's giving us both of these commands because I didn't comment out the other one, and we haven't received any connection. So I always assume that there is no curl, wget, anything like that on there, that we have to just kind of do a reverse shell. So we're going to go back in here. And what I'm going to do this time is I'm going to comment out both of these. And we're going to go to our reverse shell. And again, if you don't have any reverse shells, there's a bunch of cheat sheets out there. You can look them up. This is what I've landed on. And what we're going to do is we are going to run this exploit again. And this time, as you can see, it hangs. There's nothing coming back. So it's a good indication to assume that we more than likely have received our reverse shell. And as it looks like here, it was received. We are a user within this application in the folder app, and what we're going to do is we're going to do an ls-l to see if there's any hidden files. Actually, we should do it la and a dot files. Nothing. Again, this is the requirements that we looked at, and we can also confirm it. You can see there's the same exact files. This was used in the server.py. Let's see if we can take a look. Somewhere in here, they are using RPC right here, and they're collecting our data, and hence why it's vulnerable. But just to finish this up and wrap it up, we're going to go look at some other folders, see if we can find our flag. And as you can see, cat flag, gives us our final flag. And if we go to the fetch the flag, we can submit it and collect our 496 points with this. So that's it. That was the whole thing. The whole point of this was to kind of show I'm an old school person. I like to do things more manually, and I'm learning more and more to rely on tools within a certain realm. I personally try to not rely on a lot of tools just because I forget things, it makes me lazy, and I become too comfortable. But in this case, it took me a lot less time, a lot less effort by just running this challenge into Snyk, and obviously made it easier because we know who's hosting the CTF, we know they have a CLI, and we know what business they're in. It's just a matter of putting those three things together, leveraging their tool, finding the right exploit, tweaking it, and getting a reverse shell. All right, last thing, do me a huge favor. If you like this content, drop me a like on the video, subscribe to the channel. If you're not a Nahomi, subscribe, become a Nahomi, and see all the other upcoming videos I'm going to drop. And outside of that, this is it. Thanks for watching. Peace.